HArquitectes, which is part of the Berlage Keynotes, our ongoing series of internationally prominent architects, designers, and thinkers who are at the forefront of design discourse, innovation, and practice. This lecture presents the work of HArquitectes, established in 2000 in Sabadell, Spain, by David, Josep, Xavier, and Roger, if I can say it like this, after completing their studies together at the Vallès School of Architecture. Their work includes the Clos Pachem Winery, the Civic Centre in Santsenca, and House 1413. And their work has most recently been compiled and presented in Croquis, volume number 203. It's a pleasure here to have Josep, to both the Berlage and the TU Delft's Faculty of Architecture and the Built Environment, to give this evening's lecture on behalf of the partners of HArquitectes. So thank you and welcome. We look forward to the presentation of your work.
Thank you, Salomon. Thank you very much for the invitation. And I'm sorry because I've changed the name of I've changed the title. So so sorry for the last moment change. Yeah. And I've changed it. I tried to explain you what I've changed that, because for us in general it's quite difficult, quite tough to explain our projects. When we explain our projects, in general, people think that we are hiding something, that we're not explaining everything, because for us, the creative process of the projection in architecture is really difficult to synthesize, to explain through smart ideas or through beautiful sections or drawings. And people believe that as we are not explaining that part of the process, we are hiding that more funny and more interesting explanation when you talk about your architecture. But it's impossible for us to do that kind of explanation. It's more funny, so at the end, our explanation became just a description of the behavior of our buildings. And as a teacher, I know that it could be so boring. So that's why, in general, before to present some examples of our buildings, I try to explain at least our general positions, our truths, let's say, or what I prefer to call our common places. Common places means for us the stuff that after 23 years working together has become something easy to be shared, the general context that gives an ethical context that gives sense, that makes sense with our decisions. Our common places began 23 years ago when we were studying at the architecture school in Barcelona. And as for people working together from the very beginning, the first common places that we found was our interest in vernacular architecture, in popular construction. And that's easy to be understood because that kind of constructions, like in the right side of the picture, are non-representative language construction, are anonymous examples of architecture. And that, when you're working four people together, the only way to come into something that could be a project is to put away of the table of discussion any kind of personal desire. It's not the only way to project, of course, but it's the only way to project as a team during 23 years. Because by arguing about your personal desires, about your personal ambitions, it's impossible to share that kind of stuff with your partners. And the vernacular, for us, at the very beginning of the office, and when we already were students, was that kind of, as non-representative language, facades and so on, is that kind of a stuff that is very easy to be shared in terms of pure composition, in terms of pure language. With time, we've discovered that vernacular construction is something more than a non-representative language example. It's also an amazing example of efficiency, is an amazing example of minimum matter to get maximum shelter and so on. And with the years, we've discovered that vernacular is not something that happened before years ago, because vernacular in terms of efficiency, vernacular in terms of pure conditions for shelter is already done today in terms of what we call contemporary vernacular, like in the left side of the picture. So that picture, which is, let's say, a present from a student like 15 years ago, shows a little bit of our evolution from that approach to the anatomic in architecture, the composition, the formal approach to the vernacular, coming into something closer to the more physiological approach to architecture, to try to understand how the different elements are related between them and so on. The title today is The Invisible, because the nature of the building is one of that common places that we've been dealing with during the last years, but our common places are something that are not in a substitution process. It's just an adding process, is a layers of concepts that we share. And what now we are more interested about is what I've titled as The Invisible, which is not, it's not about metaphysics or about poetic approach to architecture. It's about the invisible in terms that something it's difficult to be catch with as a picture, but something as objective as the rest of the elements in architecture. I'm talking about that part of architecture that cannot be seen, but is as important as the air, or as the time, or as the convection of the air, and so on. But of course that we began with the visible, so all that common places that began like 23 years ago began with that more anatomic approach to architecture. On that interest with vernacular, our first examples were concerned about try to look like our neighbors, try to look like that kind of popular dwellings that are in our neighborhoods, in just close to the office. This is one of our first examples, a small house done just 4 streets from our office, trying just to understand the composition rules of that kind of popular construction, of that kind of dwellings that are on our streets. So it was just a formal approach. It was just about composition, trying to understand that rules in terms of more vertical than horizontal halls, trying to avoid, trying to erase the idea of parking entrance in the facades and so on. But we quite quick we understood that kind of formal approach, or that kind of formal reasons or compositions were based on a structural behavior, which is that kind of halls, that kind of proportions were just the result of a structural behavior, which is the behavior of a structural bearing wall. Just a wall that is working just in compressive sense, is that structural behavior that was the reason why the halls were in that proportion and so on. So after that first approach to a more formal approach, we began to do that kind of houses where the facades, at least the facade, was a real structural wall working as a bearing wall and nothing else, not hiding another concrete structure or steel structure. This one of the first houses that we did in that way. After the idea of a compressive wall as the reason for the facade, we understood that the compressive walls are part of a system. It's not only the facade, it's not only the structural walls itself, it's also the perpendicular walls that stabilize the whole system. So and that is something that for us was a big discovery, because it was not only about to understand that the whole a building is the result of a structural system. It's also a system that gives you rules in terms of typology, in terms of how you deal with the idea of a space and program based on structural rules, not only in terms of composition, not only in terms of facade, but also in terms of typology. And after that idea of that behind the structural wall, there's a system in terms of structural behavior, we discovered that it's not only about structural, it's also in terms of comfort, in terms of real experience, that with that kind of systems is included also an idea of comfort based in the idea of cross ventilation and mass inertia in order to stabilize indoor conditions. So it's been more or less our process during the last 20 years, coming from that more anatomic approach into that more performatic approach, but always in that interest from the vernacular, but trying to understand deeper and deeper the reasons for the final result of that kind of vernaculars that we were interested. Now we are like in a coming to the very origin of the stuff, trying to do all that which is comfort and structure through that kind of structural wall systems, but doing it with just one layer wall, giving to the design through the design of that kind of enclosure systems, putting all the attributes into just one wall matter. So as in this house that I will explain later, that is a house with where all the attributes, not only the structural but also in terms of insulation, are placed in a just one layer wall. So it's not a double layer facade and so on. It's just a one wall facade. So this is more or less, but this is a more or less logical evolution from that anatomic to the physiologic approach. But now we have understood, or more or less, we are in that new common place that we are dealing with, which is what we call the invisible, which is just that we have understood that at the end, what at the end produces a human experience is not the visible part of architecture, but is the invisible, because basically it's through the air that we get the experience into architecture. And at the end, we are just focused, we are just concerned about to produce an experience in people. And that experience, of course, that we're always concerned about that, but our soft change of view is that we believe that we have to design conditions that manage the invisible in architecture in order to produce that kind of human experience. The invisible in architecture, which is the obvious, the air, the temperature, the thermodynamics in general into architecture, have to become visible, have to become evident through human experience. So it sounds like really serious, but it's just as fun as talking with your partners, that we have that sensation, we have that feeling that we are projecting the human experience. We're not projecting anymore a building, we're not projecting anymore an object, we are projecting the human experience, the performatic part of people into architecture. And in order to get that, you have to design a matter organization that produce conditions for that. So, as is difficult to explain, I always use that painting, which is a painting from a Catalan really skilled painter called Ramon Casas, who painted that beautiful painting, and the title of the painting is really a manifesto, because the title of the painting is An Indoor in the Outdoor, an inside in the outside. So that's the original title in Catalan is like that. So, and it's just that beautiful moment of the nap of his brother-in-law with his sister on the summer house of the family, just getting that beautiful experience, not only thanks to the summertime, but thanks to the natural conditions managed with architectonic design. Because here, behind that beautiful experience of that moment, there's a mass, big walls, cross ventilation because of the two facades of the house, the shadow of the canopies and so on. So I think it's a good image to understand a little bit what means for us the idea of invisible, which is just to produce an experience in people. An experience that should be not only physical but also emotional, because it has to be something else than just survive. Architecture is something else than give survival conditions. It means also luxury, but in terms of just pure human feeling. As a pure abstraction, I always use this diagram to talk about the invisible, because the most abstract concept to talk about the invisible in architecture is to talk about time. Time is the big abstract concept that included in time through all the vectors that time can assume through the reality. We can talk about that invisible part in architecture. And I use this diagram, which is also a manifesto itself, because it's a diagram that my partner did a lot of years ago for his PhD, doing the calculation of the weight of a 100 square meter house that we did at the office. So he did the weight of all the parts of the house. On the left side, you have the solid weight part of the house, which is the dark gray, okay? Also the liquid part of the house, which is the second gray, and the lighter gray on the top is the gaseous part of the house, which is mean the air into the house also have a very small weight, so it's a very small proportion of the whole weight of the house. The diagram on the right side is the same house, is the same concepts, but it's the same calculation but for a year. The same weight per year means that the solid part of the house, of course, that doesn't change, but the liquid and the gaseous is continuing changing and moving because it's in a renovation process. It's not as important to understand the difference, but what is obvious at the end is that what is real, what is absolutely real, is the right part of the diagram. The left side doesn't exist. Nothing exists without time. So when you put time into the equation, you understand how important is the invisible in architecture. The invisible, I insist, not in terms of poetry. The invisible just in terms of pure physics and natural conditions, which is the air. Because it's through the air, through that invisible part of architecture, that we get our basic sensations. Because architecture is something that you just feel in a very subjective, instant experience, non-intellectual. It's the same experience for me than for my mother, who is not an architect. So the air is that interface that is constructing, building my personal experience into architecture. So talk about the invisible is talk about time. In terms of abstract, if we try to transform in something more pragmatic, something more concrete, what means, at least for us, I insist, I'm not trying to do a dogma, I'm not trying to explain a general truth. It's just our basic common places that we share in order to be productive and to project in the day-to-day office. So to talk in more specific, to the 3 vectors or 4 vectors that we use in order to talk about time, but by projecting, first of all is to project by taking care about the human performance. Human performance is the first vector, the first evident aspect about projecting that is based on time. To project the people performance is to project with time. To project, projecting the natural conditions performance is to project with time, natural conditions and physical conditions. To projecting the building performance, understanding that a building is something that changes, that's something that is in a continuous change of behaviors, is also to project taking care, being concerned about the concept of time into our projects. And project with the human performance is also the first way to introduce sustainability concepts in our projections, because architecture is not exactly, the objects are not sustainable or unsustainable. It's the use that we get from the objects that could be sustainable or unsustainable. So by projecting the human performance in our buildings is one of the easiest way to introduce sustainability strategies into our projects. To project with natural conditions, to project by imagining how we can get from the natural conditions, managing those conditions, dealing with it, is also a way to get real luxury into our projects. The luxury understood not about I insist, not to survive into our buildings, but to be as good as possible. And to project by understanding the idea of the performance in the buildings is the best way to have what we call in Spanish really strong strategies to have certain level of guarantee that our buildings will survive over the specific programs that is demanded at the very beginning. Because history of the buildings, and this building is an example of that, isn't it? It wasn't designed to be an architecture faculty, and it looks like not a bad place to study or to be at the Berlage Center. So we have to design by understanding that the performance of the building is not about specific programs, it's about to give good conditions for shelter to people. And by doing that, using the natural behavior of the building, is the guarantee that is to have the guarantee that that building will work in that way over the specific program that is assuming today or in the future. So those three vectors, or these three interpretations about what means time in architecture, is what in general, is what we are nowadays talking about in the office. Of course, that there's the traditional idea of project with time means also to project with heritage, to project with the pre-existence. In that sense, our position is that the best way to give, to work with the heritage, to work with the pre-existence, before to deal with the heritage in terms of composition, in terms of pure culture, we prefer to deal with the heritage in terms of, again, in terms of behavior. We always ask to the pre-existence if it's already able to give us certain attributes into the new building. So that's, in our opinion, the best way to deal with the heritage, to deal with that kind of pre-existing buildings, is not to protect that just because in terms of culture we assume that it has to be protected or it has a certain value, but to use that because there's a lot of attributes that are already on that organized matter that can help to produce that idea of comfort or that idea of a structural performance into the designs. Also, and this is not easy to explain, but there's something else about the invisible that for us is the extraordinary, what we call the extraordinary, that is difficult to define. But in general, I would say that it has a lot to be. There's a Jacques Zonderlat concept that he explained very well, far better than me, which is something like, Zonderlat explained that the functionalism compromises freedom of use. This is a sentence that the first time I wrote it, it was a little bit surprising to me because I'm an architect formed in that general idea, as you are, of the modern movement from the 20s. At the end, our heritage is that, more or less, 20 years younger than me, but we are more or less on that general conceptual context. And in that context, functionalism, la máquina de vivir, the machine to live, or freedom of use, the polyvalent spaces, free spaces, are part of our context. But Zonderlat says that is the opposite, because if something is highly specialized, it's very difficult to be used in different and free ways. So, and I think that he's a big certain, he's a big true. And in that sense, I believe that the extraordinary, if it exists in our spaces, is based that the attributes, that what is special in that spaces is not based in the specific program, is not based in the specific use of that spaces, like this weird, strange entrance to a house that works as a dining room in summer, and it works always as also as an entrance, and works also as a child's courtyard sometimes, and so on. The extraordinary in this space is not based in the use, but based in the attributes in terms of architecture. So that's our common places from the 23 years ago to this moment, always in that very specific general common place, which is vernacular, which is popular construction, is something that still today is important for us, because as I've said at the beginning, it's simple to share that kind of examples, that kind of reference for a four-people team. But coming from that really visible approach, that really formal approach, coming to that moment that we are today, which is more concerned about the invisible parts of architecture, the invisible attributes of space, in order to produce a human and emotional experience. To explain that also, and to give you some examples, I bring some, not the last projects of the office, but 5 or 6 projects that I think that could be, I won't explain the whole project, I will just explain parts of the projects in order to explain a little bit that performatic part of architecture, or at least what we understand as the performatic part of our architecture. Like 10 years ago, we won a competition for a research center in university, in the Autonomous University of Barcelona. And I used this project to explain something that is a strategy of the office, and I think that we still believe that is important, or at least is something very characteristic of our way of design. In general, I've never met any architect that doesn't assume or doesn't try to deal with that very complex equation that means to be architect, that means to take from one side the demands, no? The demands in terms of norms, in terms of budget, in terms of program, so on, and on the other side, to take the availabilities, no? What is close, what I know, what is cheap, what is possible, and to put it together in a very complex equation. I think that all the architects in the world try to do a little bit the same to succeed in that very difficult equation of demands and availabilities. And we do the same. But I think that maybe what is a little bit specific of our office is that what we try is that the two very basic parts of any building, which is structure that gives support for people performance, and the envelopment, the enclosure, the outdoor surface that protects that activity from the climate and so on, those two parts, those two very elemental parts that every building has, we try to ask those two very elemental parts to perform in maximum number of roles possible, not only as a structure, but also helping to the comfort experience with the inertia, with the mass, helping to the acoustic conditions by designing the surface, or helping in order to introduce the renovating air system into the structural shape. And the same with the envelopment, with the protection, with the facade, which is asking the facade not only to be the rainproof system of the building, but also to be the part that produces a cross ventilation, the part that protects from the sun, the parts that open and close, and so on. So then I think that this is very specific of the office, that ask those elemental parts of the building to perform in large number of roles as possible in order to produce, to go from the elemental to what we call the fundamental. So in that sense, I show you this building, which is a research building, which is very clear, those two parts, which is the strategy of the building is really simple. Is a greenhouse in winter and is a pure open space and shadow in summertime. So the left side is the basic behavior in wintertime, and the right side is the summertime behavior of the building, with this very simple concept, which is a building which is not a building with a greenhouse on the top, which was part of the demands of the competition, because this is an environmental research center. So they asked for greenhouses on the roof, on the top of the building. So what we decided to do is to develop that idea of, which is a greenhouse with a building inside. The greenhouse works as a greenhouse in winter, and the whole facades open in order to produce shadows and to produce cross ventilation with the inside courtyards in summertime. So then the real program in terms of office and meeting rooms is smaller than the whole surface, and it's full of that kind of intermediate space. The whole intermediate space of this building has no active systems. It's pure passive. It works just with the inertia and the cross ventilation. So it's nothing else, and it works quite well. So we get in that intermediate spaces from 18 degrees to 28 degrees. And as it's not real meeting rooms, or is not just is that kind of intermediate, it works the whole year quite well. So, but just to show you those two elemental parts, I want to show you, this is the structure, which is a really heavy slab, 40 centimeters slab. It's that measure because it's that dimension because we try to do large distance between columns in order to have a more free space in the whole plan. That give us a lot of inertia, which is very interesting in order to temperate during the whole year all those, not only the intermediate spaces but also the indoor spaces into the timber boxes. So, but this is not just on a slab, because it's also by putting that kind of pipes into the slab is also a system, the renovation air system is going through the slabs in order to get to use the inertia not only for the spaces but also using the inertia to give better conditions to the renovating air system. And also you can see how the silhouette of the slab is like a curvy silhouette in order to have more interchange surface, but also to help to the acoustic conditions. Well, it's what I was trying to explain, that we asked to the structure to don't be not only the structure, but it's also the comfort system, because in terms of inertia helps to the comfort, but also has an active system through the slabs to produce, to put the slab in temperature in summer or in winter into the offices spaces. So this was the exciting moment before to put the concrete into the slab. I know that the concrete has a very bad image in terms of sustainability, but we have to understand that in this case, there's a half part of the building is completely renewable. So it can be changed every 10 years, let's say, the envelopment, the enclosure. And we decided that the structure, with all those attributes in its nature, because it's in the nature of the structure to have a lot of inertia, will be there over years and years. So it's a different idea of the idea of large presence of the building is also an idea, I don't know the name in English, but amortizar, to use it as larger number of years as possible. On the other hand, so this is the inside image of those courtyards that produce the vertical movement of the air as a natural engine from the different spaces, from the different facades to the rooftop because of the courtyards. This is a very, so the maximum number of the attributes of the indoor space is because of the structure. We always try to get the maximum of attributes with the minimum of the elements. On the other side, there's the facade, the rainproof system of a building, of any building, that is not only that, is not only a movement, natural movement of the air, and is also is a greenhouse effect, and is a pure catalog system, is a pure Lacaton Basal concept, let's say. It's architecture from a catalog. You can buy it by phone. It's the most available system possible. But it's not only the rainproof, it's also the rest of attributes needs for the inside comfort. Also works as a real greenhouse in the top. And that's the image. Well, talking about what I've said before about the preexistence, about the heritage, this is the first attribute that we look into the heritage, into the preexisting. The first attribute is the geometrical attribute. Before of the inertia, before of the mass, before of the culture, the composition, or whatever, the first that we ask into the heritage, to the preexisting, is in terms of pure geometry, what is still able to assume into those spaces. It's very simple, is easy to be understood, and in that case that it was also a competition, that it was open to the only part that was protected from that building was the facade. You can demolish all the indoor elements of the building. We decided to demolish the part and to keep there another part. And we decide that in terms of geometrical attributes of the preexistence, not in terms of culture, not in terms of history. What we understood from the research, we did a really large research to understand all the moments, the historical moments of the different indoor walls of that building. But the final decision wasn't in terms of history, it was in terms of that if we demolish those specific structural parts of the building, we get far more, we get new behaviors far better than the former ones. So by demolishing that narrow structural parts of the building, we get a new intermediate space that is not only producing a natural engine effect by moving the air in vertical, is also getting some sun gains from the roof, but it is also producing a new space where what is not programmed happen, what is unexpected happen just in that kind of spaces. The rest of spaces, the former spaces, the already there spaces, we just decided in terms of pure geometry that were interesting enough to assume the new program that the competition was asking for. So by demolishing just a part of the building, we get that kind of free spaces that are not just for circulation, but is also the way out of the renovation of the air coming from the most regular and programmed spaces. So this, for example, is the former, this used to be a workers' cooperative. So in that kind of buildings, in that kind of programs, used to have a big general store where they didn't use real money. They used like some kind of bonus or something like that. And this used to be the general store of the cooperative, of the worker cooperative, and now is a rehearsal rooms. So in terms of the competition demands, this room wasn't big enough for the demands. But in our opinion, if you compare, if you look at the attributes of the space, was good enough to become the rehearsal rooms. On the other hand, there's another part of the building that was better to be demolished in order to get that kind of vertical spaces for circulation and to get natural light and to produce cross ventilation and so on. So the former spaces for theater needs more attributes in terms of sound insulation, but at the same time, in terms of memory, in terms of geometry, we're still able to assume, for example, this was the general meeting room of the cooperative, now is a theater, because in terms of dimension, in terms of height, in terms of position, in terms of access, our decision was that in terms of geometry was good enough to keep it there and to become a theater. Another attribute, of course, that we look into the pre-existing is the structural behavior, how if that organized matter that is already there is still able to work in terms of a structure, if it's still able to support the new program and so on. This is a competition that we won for a theater in Barcelona that is still not built. We hope to build it next year or maybe the other. But I explained that as fast as possible because in that sense, that building, in general, we always use the pre-existence in terms of structure support because the walls are there. In general, we love to work with that structural wall system because give us not only support but also inertia, so helps in terms of comfort and so on. But in that case, that theater is a theater in Barcelona, very typical on that area called El Paralelo, close to the port in Barcelona, which used to be a very famous music hall avenue in Barcelona. But that kind of buildings used to be buildings that used to be built very, very fast because of economic reasons and also because of legal reasons. People asked not for music halls or for theaters, they were asking for typical industrial buildings built just with very light timber structure with very light beams, steel beams over it. So the Arnau Theatre is the last one of those kind of construction that still remains on that avenue. So the beautiful part of the building is the last example of that kind of timber structures. So, but after 150 years of life, the timber doesn't support anything anymore. So it's impossible to put the new program in terms of a structure over the existing structure in terms of timber. It's completely putrefacted. So, but we have discovered a couple of ways to take advantage from that former structure. In one hand, it's just the pure construction of the indoor atmosphere. That beautiful timber structure, by taking some extra weight from it, will produce, well, as the new theater, it's far more, it's that kind of Peter Brook ideas theater and so on. It's far more flexible, completely flat. We just want one of the upper levels for the audience. So the rest of the levels gonna be naked partially in order to give that image, which is to produce the experience of the vertical spaces of the theater by looking all that former timber structures. Okay, so it's like that in order to explain the origin of the building and to produce that kind of vertical spaces with all the memory, and we think that it's going to be beautiful. But this is not the important approach to keep the timber structure there. What we propose, and it's been accepted and we will try to do, is that all that timber vertical structure will be part of the precast system for the new structure. What wasn't the structural part of the wall will be taken off, and we will be substituted by a new concrete structural wall. But to give shape to the concrete, we will use the original timber columns to support the precast system for the concrete, okay? Not only in the vertical, but also in the horizontal, giving at the end a beautiful image. I don't know the name of that, sorry. Yeah, giving that kind of you know, that Japanese tradition to put together again the pieces of something which is broken. So It's a little bit that kind of, well, we are taking off the clay walls, which are not structural, and we are putting there a concrete structural wall, but we use the timber columns that are not able to support slabs and to be legal and so on, but is still resistant enough to support the precast system that will give shape to the concrete. Just trying to explain specific parts of those examples to understand. I'm sorry, now it's a little bit blocked. He's thinking. I'm sorry, I'll try to close it maybe. Yeah. Okay, sorry for the interruption. I was talking about the air. I'm coming back to the air. This is an example about is a building that we've done. Is a facility, a social facility that now is an adult school and well, something for elderly people to learn Catalan and so on. But I want to explain just this example in order to explain how in this case, by using the structure, we are giving attributes to the air, which at the end is the air that really produce the real human experience into spaces, not only in terms of geometry and dimension, but also in terms of temperature, humidity, smelling, and so on. So this is a competition that it used to have two very difficult conditions. In one hand, on the other hand, two of the facades were occupied by protected facade from a former old factory that used to be in that part. The factory used to be huge. Just because of the growth of the city, the rest of the factory is just that very bizarre shaped plot with those two big walls designed to be a factory that now has to assume a scholarship program, basically classrooms. 70% of the program is basically classrooms. So the height of the old facade, the difference between the proportion of the halls, the south facade was the large facade of the factory. So that means in order to get natural light for the classrooms, we decided the first strategy, very basic strategy, that was to do a 2 meter step behind of the facade to get more levels than the composition levels that the original facade has. So to get four floors for the new building, we do that step behind in order to produce that courtyard, to get more natural light and to be free to design, to give dimensions to the different stories, and also to give free dimensions to the new windows. After that, we decided that the basic behavior of the building gonna be like the first research center I explained, a little bit like a greenhouse in wintertime. In wintertime, with a small classroom and 25 adults inside, is absolutely unnecessary in Barcelona to have a heating active system, because just with you know that you are natural walking ovens people, so in that building was absolutely unnecessary. In summertime is completely the opposite, so we need to ventilate a lot in order to take off all the excess of heat because of the people. So the building works as a greenhouse in winter and as a courtyard and as a natural engine to move the air in a natural way to take off all the excess of human heat. But just to, in terms of program, it's really simple. It's just a corridor in the middle with program both sides, placing the classrooms in the larger facade and the administrative part of the program and the opposite facade. And it's not quite interesting. What is interesting, at least in my opinion, is that the structure that again is a compressive wall system based on that idea to put a lot of inertia, as much as inertia as possible, into the spaces in order to get a softer interior climate, which is simple to understand in Barcelona. We are a city that we live close to the sea. The sea gives us a lot of inertia, and that's the reason why Barcelona has a softer temperature average than just 100 kilometers inside of Catalonia, where the temperatures are like bigger difference between summer and winter and so on. So the inertia, thanks to the structure in that building, is the reason that why the average of temperatures are not really a big difference between day and night and summer and winter. But at the same time, is the same structural system that to be free in that horizontal way, the walls need all that small horns in order to stabilize the system, and at the same time is not a structural element, is also the pipe, the structure takes shape to be more stable, but at the same time is the pipe to move the air across the building. Well, all that I'm not able, you can see it. Well, it doesn't matter. So the building is basically that structural system in order to put inertia and so on, but what is more or less interesting is that section where that idea to manage to give attributes to the air as the basic tool to produce comfort into the spaces is thanks also to the structure. Is the structure in terms of geometry, is the structure in terms of its self-stability that produce pipes to produce spaces that are the natural movement of the air, okay? So the air is the same not only to renovate it in terms of healthy reasons, but also in terms of comfort reasons to take off the excess of heat in summer. To do all that, we have two basic elements, everything into the structure, the inertia and also active pavements, active system pavements with pipes with cold water or hot water to produce the comfort conditions. But what is important in that project is not that part. The big challenge in that project was not only to produce comfort with the inertia and with the geometry, but also to move the whole air without using any kind of artificial fan. Okay, so all the air that in summertime it's about 15,000 volume meters of air per hour is moved thanks to a natural engine, which is that strange shapes in the roof of the building. Okay, this is sun chimney. This is sun chimneys. Well, in fact, it's three different natural engines. Is the sun chimney effect. That means that is a greenhouse effect in the pyramid part of the chimney, okay? You need a captive layer and an absorbing layer, which is the black one, and that air in between in summertime because of the sun energy coming to 90 degrees, and this is for real. We've done not only the simulations, but we've checked it we monitorized the building, and that hot air goes up, of course, and because of the depression that this movement produces, the whole inside air has to move up to do the substitution of the air, okay? So, and that's why the chimneys have this shape, because of course that this is a physical effect. This is nothing to do with an engine or it's plastic, but it's a pure physical effect. It will never get broken. It will be forever. This is pure thermodynamics. So the 15,000 volume meters of air that is moving every summer, every hour, is thanks to a physical effect. It's not because of design. So it's not a design, the shape of the chimney, because those are the angles of the sun during the day. Okay, so to the east is one kind of a slope, to the south is another slope, to the west is another slope. So we designed all this thanks to some engineers able to understand that we don't want to solve that kind of problem with engines, but we need them to do the simulations enough to design that kind of natural engines. And thanks to that people doing simulations, we defined that sun chimney element. There's also a chimney effect, which is before, if you have more than 9 meters difference of height between between the chimney and the last space, you also have a typical chimney effect in terms of vertical movement. And you have a third natural effect, which is the Venturi hat of the chimney that works at night, because it's at night that you have also to take off a lot of the excess of heat during the day. So the sun chimney, in fact, is 3 different natural physical effects. This is also a, well, I'm talking too much, I'm sorry, because I'm coming into a, well, that's the kind of problem that we have when we describe our project, that became boring and boring because you explain that kind of concepts that are not really funny and doesn't explain the exciting of the design. But is what is really exciting in that building is that when you go to the monetize, you really realize that 15,000 meters of air is moving per hour. So it's like amazing, because you are into those spaces and you feel that the air is moving as natural air, which is a close, because this is classrooms. Classrooms cannot be open at summertime because you have the noise of the street, you have the noise of the corridor, so you have natural movement of air thanks to that natural engines on the top that is moving through the structural geometry without having any annoying noise from the other classrooms and so on. So that's what is interesting of the section. The section is the same in the south with that facade and that courtyard that you can see here with the sun chimneys on the top. This is the south courtyard between the two facades. But it's the same in the north. But because of the geometry, the courtyard is completely different, but it's the same idea. In this case, that is the entrance courtyard. You use that as an entry. The other one is not for people because it's just for the movement and to give conditions to the air. Okay, so the air coming to the bedroom, into the classroom, sorry. Winter time with the CO2 lecture, and in summertime because of temperature lecture. So, well, it works quite well, and at the same time, it gives you an experience which is not only about temperature, it's not only about humidity, which are based on that idea of natural movement of the air, natural ways to get good temperature and so on. Is also about that idea to show how the structures performs, how the structure helps giving you inertia, and to show all the geometry and all the behavior of the structure. Taking too long. Okay, I'm ending. So this is a winery that we've done in the south of Catalonia. It's a beautiful place called El Priorat. is a non very well known wine region, at least not really well done out of Spain. In Catalonia is really well known, and they got amazing wines. And it's beautiful because in this area, which traditionally is really hard, it's really tough to get wine because of the topography, very hard topography, difficult to do agriculture, to have that kind of, it's not flat, it's really difficult. The tradition of that kind of business was completely familiar business, just very small plots, small productions, and so on. That's why, in general, the tradition in this area is that the wineries are into the towns, are really small wineries, not in the middle of the landscape, but into the towns, in the downstairs, in the basement of the houses, just as small as that. So, in this case, this is a guy that bought an existing winery, but they used to do the wine in the middle of the landscape with a warehouse, really simple systems and so on. Good wine, but not in a beautiful building to do the representative part of the business and so on. So they asked us to do that winery into Gratallops, which is the name of that beautiful village. And to do that, he bought like 5 former small houses, attached houses. One of the plots was not a house, was a fronton. A fronton is that kind of walls that people in the towns used to play with, like a tennis ball, but harder. So that's what we call fronton. And so it's just close to the church, so it's a really nice place, and the plot is perfect with that presence of the church. But the urban strategy is really simple. It's what we call a typeset strategy. When we were in our 4th year career, my partner Xavi did a project for the typeset studio, which was exactly like that. And 25 years ago, after, we're still using the same strategy, which is when you're playing or when you're working in front of typical party walls, partition walls, with the former geometries, we always try to do a more regular program solution in the corner, and then to take advantage of that beautiful geometry that is produced between the regular shape of the building and the specific shape and beauty of the partition walls. Okay, so that's a typeset strategy that we still use in that case. So the norms ask us to be away from the part of the partition wall. We decided to concentrate a lot the indoor program, the vinification process, and to have all that free space in order to do the logistics of the process, to get the grapes, to do the vendome, well, I don't know the name in English. Well, you know, when you get the grapes and so on, all the process, part of the logistics is done in that outdoor corridor, and the vinification and the technical process is done into the box, let's say. So that produced two very different kind of spaces. The first one is easy to be imagined, is that kind of a street that surrounds the vinification building. It works as a real street. It's completely open, just covered by open roofs with green roofs with some greenery and so on. It works as a small hall. It works as a small store. It works as a bar in certain moments. It's the open space to introduce the grapes into the building and so on. Is that left part of the building? And well, it's beautiful, but it was not the part that I want to talk about, which is about the fluid part of the building and how we manage again the air into that building. That's that street, let's say street, which surrounds the building. But what is interesting, in my opinion, talking about that fluid part of architecture, is how we designed that vinification building. All those multi-layers walls is again a strategy to put as much as inertia as possible into the space, okay? This building again has not an active heating system, and it has to be between 14 and 20 degrees the whole year. In summertime, this is a very hot area, and in wintertime, it could be cold. The cold is not a big problem for the vinification process, but the excess of hot could be a problem, okay? The process itself is an exothermic system, a process, but is controlled by the pipes and so on. But the space has to be in specific conditions, okay, between those 14 and 20 degrees during the whole year. And we get that just with the thermodynamics of that design, which is a lot of inertia with the structural walls, as much as possible doing that kind of multi-layer walls. Sorry. Those structural walls that supports also ceramic beams crossing the space works like that to produce as much as surface as possible to do the interchange between the air and the inertia of the structure, okay? So that's why the wall is not just one layer wall, it's a multi-layer wall, in order that thanks to the convection of the air goes through the walls, touching all those surfaces and getting advantage from the inertia to do that kind of, to make the to make softer, atemperar, to temperate the air conditions. So that's the and also it's really beautiful. We've done the whole building with just one model brick, which is 10 per 10 centimeters. So it can be it's 10 per 10 per 20, so it can be work in both directions. But it's a catalog brick. It's not a specific design for the building, but we've been looking for a lot of bricks till we found that one. So, but you understand the section, but you will see. When the outdoor conditions are good enough, we just produce an opening on the top in order to get that cross ventilation and to put the outdoor conditions inside. You have to imagine that in Barcelona, 75% of the hours during the day are good enough to live in the street. The problem is the low level of qualities of our buildings. Is worse to live inside than to live outside, at least in my city. So it's not so amazing or so bizarre that just by opening some windows and taking advantage from the inertia, lot of hours during the year, you can be as good as is necessary for that kind of, which is between 14 and 20 degrees, okay? But this is a regular, typical convection, cross-ventilation system and so on. What is funny, beautiful, interesting of that building is that we've developed like a swimming pool in the roof. That swimming pool is a very thin layer of water, just 10 centimeters, 15 centimeters of water, that during the night, the water is just outdoor, okay? Getting freshness from the sky, okay? You have to know, it's in terms of thermodynamics that you interchange, that you're giving energy to something that is more fresh or is more cold than you. So the sky is far more colder and has a lot of inertia, far more than the water itself. So there's a high level of interchange with the sky during the night. Even at summertime, especially at summertime, is interesting, that process. During the day, the water goes down just to the chamber below, okay? Giving that freshness that he gets during the night to the structure. So the structure during the day, it's getting colder because of the touch of the water, okay? So it's just conduction, okay? The conduction of the fresh from the water to the structure. So the air that it gets hot and goes up, touch to the structure, moves horizontally and goes down again, producing that interesting convection movement that it was simulated, of course. It was not just a pure intuition of architect. It doesn't exist. We did hundreds and hundreds of simulations in order to get that idea and to check it. And now that we've built the building, we've checked that it already works. Okay, so that's the basic idea, which works quite well, which is to not only to use the water because it has a lot of inertia and it gets cold and faster than other systems, but also to put that freshness into the structure, giving all that cold to the air and producing that movement. Okay, so this is the inside space with all the bins. The bins has parts that are open, so the air moves on that direction and goes down through the walls. And this is the swimming pool. Okay, and just to end, well, I'm really ending now. This is the last real project. So whatever I've explained, what is still what is still a real clear concept for us, what still now surprises us, really liked us, and it's not exactly about the vernacular, it's about a specific kind of constructions that a structure and the geometry of the space is the same. The structural elements and the geometry that defines the space is the same. That kind of, and you can find examples of that in vernacular, but also in classical, in a lot of examples, that still now, when we visit that kind of buildings, when we are there, when we are in places like that, this is a real query in Mallorca, okay? When you are in that kind of spaces where the structural and the geometry is the same, we still get excited. 25 years after we discovered that kind of stuff that we share the four together, still now we recognize in that kind of constructions that the attribute of the experience is in just one place, and this is very powerful. This is absolutely powerful. I advise you, if you visit Mallorca, please try to find out where are that kind of quarries are possible to be visited, and it's amazing because this is a real quarry, an ongoing business. This is not just a vintage space, the former way that they get the Marès stone, the limestone, and so on. No, this is a real quarry. It's an amazing space. So we still get excited with that kind of examples where structure and space is the same. And just to end, I explain you that house that we've done in a beautiful village in L'Empordà. L'Empordà is a very typical summertime area in the north in the Costa Brava. I don't know if it sounds to you, but in the inside part of the Costa Brava landscape, and beautiful old villages, that kind with walls and so on. This village is really characteristic, not only because of the medieval old part, but also because the surrounding of the medieval part is defined by that kind of huge walls of stone that define not only plots, but also the agricultural plots. Okay, so the narrow streets of the surrounding of the village is also defined by 3-4 meters high walls made of stone that were protecting not real houses, but agricultural plots and so on. So the commission here was to do a weekend house in that kind of plot. And, well, we were excited. This was the plot at the very beginning of the moment, of the process. A beautiful place, very well orientated, facing to the south, and also with nice views to the medieval part of the town. Ullastret is the name of the town. And so we decided that the basic reference, that the basic tool to make sense in that place, in that beautiful place, was to work with the wall. So there's a wall, so the house gonna be the wall, okay? So we designed a house that was the former wall, just like a porch house, attached, linked to the existing wall. Okay, just making some holes to the street, and the rest of the house facing to the rest of the beautiful plot and so on. So we were completely agree with the client, and we were happy of the decision because of the beautiful wall. But we went to the council, and they told to us that it was not possible anymore because the street has to be wider because of the vans and because of the lorries that cannot turn the corner. So all our idea disappeared in the air because the wall has to be demolished in order to get 1.5 meters more of width in both streets, as you can see in the drawing. We were completely destroyed, crying, and so on, because... But there's a sentence in Spanish, I don't know how to translate it, but it's something like, it's no hay mal que por bien no venga. That means there's no worse, or there's no bad, because after the bad comes the good, something like that. When something bad happens, something good is coming. And it's always like this. So coming back to the heritage concept, that before of a cultural approach to the heritage, we ask the heritage its attributes, if it's already something there that can help to the project. But the wall was demolished, so nothing else remains. But something remains. What remains there was the stone. The old wall, the former wall, has to be demolished, but the stone are already there. So the project was the same to develop a porch house attached to the wall, but the wall is not the same, but it's the same stones. So we just demolish the stones, not demolish, but desmontar, well, detach it, okay? We demolished the wall, and we did new walls in a cyclopic concrete, okay, without any kind of reinforced bars, without any kind of steel bars, using lime instead of cement, okay, using just natural limes, using the plot stones, mixing it with the earth of the place, so doing that kind of artistic process, beautiful process, checking colors, but just using the limes of the place and so on, in order to produce these very wide walls, like 60 centimeters with a lot of inertia again. This was the example that I've said at the beginning, that is a just one-layer house. Is not, so all the attributes that you ask to the enclosure of a house are placed in just one wall, okay? So, because it's not only structural, it also has like very small glass insulated air balls that gives a certain level of insulation to the wall. Don't try it here, please. Forget what I'm explaining. This only can work more or less in South Europe, okay? But in this case, was enough to have a certain level of insulation. Remember that this is a weekend house. It has no heating systems. It has not artificial heating system. It just works with the width of the wall, with that insulated air balls, giving a certain level of inertia, placing that the biggest stone at the bottom, because it's more necessary in terms of structural behavior, placing the light part of the stones and that glass balls in the top of the wall. So we produced that using also the stones, and this is the nice part of the story, because it has a final, there's an end for the story, that we place the stones in function of the position, if it's for the facade or if it's for inside walls, because the council was asking us to demolish the wall, but the same council normative asked for facades with the stones, which is that kind of what we call crocanti, which is like really, it's like nasty, that to produce that idea of fake vernacular, fake everything. So, but here you see, we place that in a very traditional system, like clay walls, traditional clay walls, which is 10 centimeters layer, 10 centimeters layer, pushing, and so on. But the end of the story is that after the process, we just, after take off because this is a precast system, it's just a pure precast system. After all that, we just, how you call that, we make some digging over the surface, taking off the former stones. So the stones shows up again in a different place. It's the same stone with the same color, with the former color, just in a new structural behavior, because this is not anymore a just pure stone wall. This is a concrete wall. But the stone is not only working structurally, it's also working in terms of pure making sense with the surroundings, okay? Because it's facing to the same facades that used to be facing during the last 100 years and so on. So this is the concrete wall that after the precast process, we just dig the surface to get that color, okay? Not in the windows, because the lime give us certain level of better conditions for the water. Okay, so you can see here how the former street, narrow, okay, has to become wider, and the new position of the facade. In the inside is completely the opposite. The house, as the original concept, still remains as a pure porch facing to the south. This is a real weekend house without any active system, means that during the week, which is closed in winter time, works as a pure greenhouse. So when they arrive in Friday, the house is like 20 degrees just because of the sun gains during the week. When they move on Sunday, it's a little bit worse in winter time. But in summer, just with the shadow and everything open, and with the cross ventilation and a lot of inertia, it works quite well. It has no active or artificial system, so it's just that pure opening to the plot. And in terms of program, it's true that there's no corridors. I mean, if you want to go to your bedroom without crossing your son's bedroom, you have to do crossing the garden. But if not, the house works in a transition from the public, from the collective to the more private space by carving or giving that sense of carving to the white walls, getting that kind of more a certain level of privacy, placing the beds on that carving moments that also hides the bathrooms. You can see that not only the wall is pure lime concrete with stones, and the roof is just that the cheapest precast beams system is really, really simple. So I will end with that picture with this, my partners, and the users and the owners. That means that it's a good, we still do that kind of meals with him every summer, so everything is going all right, at least till the moment. So with that picture, I just thank you for the moment. Thank you very much.
Thank you, Josep, for your wonderful presentation. Since we're going slightly over time, there's a limited Q&A session going on. I know there are some students who have prepared some questions, so please come down and please feel free to adjust this microphone stand as well.
This new way of doing. I really enjoyed your fascination about the vernacular and the addition of the notion of the thermodynamics. And you were mentioning that while you were designing cristallerias, you were working with engineers that were creating these simulations. But if the air for you is a design tool also at your office, how do you work within your practice, within your team, like designing with air? I mean, is it also through physical models? Is it,
yeah.
How does it work?
Well, it's difficult to explain that just in a scientific chronology, okay? It's not like that. We project as you project, which is in that kind of mixing, blurring ideas, different moments, excitation, non-excitation, and so on. But during the whole process, from the very beginning, of course that we have a certain level of knowledge in terms of thermodynamics. My partner and me, we've been teaching in constructive department, in the construction department, not only at projects department. So we have a certain level of knowledge, general concepts. But from the very beginning and from the last 15 years, we've been in a collaboration process with a group of architects, not engineers, that they are called Organic Society, that they gave us that help in terms of simulation and also in terms of pure discussion. We argue with them. Let's say that, for example, the case of Cristalleries Planell, it was 1 day per week, every Friday afternoon. We did a meeting during 1 year, so like 50 meetings with that people, not only them, but also engineers, checking the new simulations, reviewing the concepts, and so on. So, of course that you need that. And you have to have a minimum of conceptualization, because the concept of the sun chimney was from us. Okay, the idea of the, well, sun chimney, you can see a sun chimney YouTube now. You can find out like 100 of different videos about how to do a sun chimney for your sons. Well, for my sons, you don't have sons, I have sons. So it's really simple, just half bottle with a glove upstairs, just placing that to under the sun, and the sun chimney effect is, and so on. So the concept was from us, because for us was like very tough solution. It works by itself. It's a natural engine that works just because we live in that world and we have physical rules and so on. But of course that you have to transform that into a very rigorous, real solution. And for that, you not only need simulations. What you need is something that, I don't know in Netherlands, but at least in Spain, is hardly to find out, which is engineers able to understand that the solution for the comfort is not based in efficiency, which is only possible to get the efficiency by the numbers of a machine, of a real engine, but by demand, by managing our demands as people about what we are asking to the buildings, which is more difficult to do the calculation, but in terms of concepts is far more strong, because the physical phenomena is forever. So, well, what I'm saying is that we really appreciate that kind of engineers, because as I'm saying, the sun chimney I've shown, it doesn't change its shape. It's designed to get the maximum of gains on morning, midday, afternoon, and so on. It works by geometry and materia, and it can get broken. But of course that you need that minimum of concepts.
Hi, thank you for your presentation. I'm actually curious about the origin of the name of the office. Where does it come from?
Well, it's from the very beginning of the explanation, in fact, because as I've said at the beginning, we are 4 partners. We were friends at the faculty. We began to work together in students' competition when we were around 19, 20 years old. And we have that basic moment of common place, which was the vernacular, but because was anonymous, because was mute, because was a non-language facades, and the H in Catalan is a non-sound letter. So we use the H, and we say we are HArquitectes, but in fact, if you read it in Catalan, you should read just architects. So that's the origin of the H, the idea of non-sound letter, non-representative language, and so on.
Hey, thank you for your lecture. I would like to ask you, how do you speculate with time and human experience while projecting? How do you speculate with time and human experiences while projecting, and how do you represent it in your drawings? Okay. Well, in the office, it's difficult to describe our process in terms of drawing, okay? Because we work a lot with models, huge models, 120 models, but just pure workshop models as big enough to watch inside and trying to imagine you as a human being into that kind of spaces and all that. So we project the performatic part of people, but we doesn't lie ourselves. I mean, it's impossible to get by drawings all that. Well, I don't know, you know that at the very beginning of Herzog and de Meuron office, they decide to don't draw never more perspective drawings, because they decided that to draw a perspective, you're always lying yourself
drawing something beautiful. So they decided that. There's another beautiful story. There's a famous Spanish sculptor, I don't know if you know him, Eduardo Chilida. Eduardo Chilida used to be an amazing craftsman, amazing sculptor, and he was the best. He began to study architecture, okay? So Chilida was a really talented, really skilled drawer, and by that time, to come into the architecture faculty means that you have to be a very good drawer. But he decided after the first year that he didn't like the world of architecture, so he decided to move to Beaux-Arts, to the Belles Arts, well, the Beaux-Arts school. But being the best drawer of his generation, okay, he decided that what he was interested about in Beaux-Arts was about the ideas, was about the world of ideas. So he decided to be 1 year drawing with the left hand, to don't lie himself with beautiful drawings, because he was concerned about the ideas, about the concepts. What I mean is that there's no conventional way to draw real life. It's impossible. It doesn't exist. It's an oxymoron. It's a contradiction in terms, okay? You cannot draw real life, but we have to project it, which is the beautiful. But what we project, what we preview is a blur, is more or less an imagination. What we can define, what we can design, and what we can draw is the conditions to manage the natural conditions in order to produce an experience. So what we can draw for sure is good, huge, constructive details. What we can do for sure is big models to try to make easier the imagination of real life, but the real life, it's impossible. But in terms of purest too, because I'm teacher too, what I ask is to draw sometimes in a specific exercise, to draw just pure furniture. Because the furniture is something quite amazing concept, which is the in-between architecture and real life. So it's not real life, but at least it's the tool to produce the colonization of architecture. And sometimes it's close to the idea of real use, not the real life, but at least the real use. So sometimes we try to draw just pure furnitures without no shape. In that sense, the big models are really useful. For example, we are really lazy workers in terms of details on the big models, but for the furnitures in the models, we work really hard because it gives you the real sense of the use. But what is essential, basic, absolutely essential for that kind of big models is to watch the models with natural light. The models has to be seen, has to be checked under natural light, because then is when you get, and also you by doing pictures, by shooting pictures, because then the effect of natural light really, it's putting you a little bit closer to the real experience of the space.
Thank you so much. We need to wrap this evening up, so one last round of applause. Thank you. Thank you.